Make a fist. Not hard, about a third of your maximum, the grip you would use on a shopping bag. Hold it for 2 minutes. Rest. Do that 4 times, 3 days a week. You will not sweat. Your heart rate will barely move. Nothing about it feels like exercise at all. And in a large analysis of the research, that particular protocol came out ahead of running, cycling, and weight training for lowering resting blood pressure. I want to be careful with that sentence because it sounds like exactly the kind of thing the internet invents. So let me be precise about what was actually compared and what it means. In 2023, a team published a network meta-analysis in a sports medicine journal, a study that pools hundreds of trials and ranks different exercise types against each other. Around 270 trials, covering roughly 16,000 participants. Aerobic training lowered blood pressure. Weight training lowered blood pressure. Both work, both are well established, and nobody is arguing otherwise. But isometric exercise, holding a muscle tight without moving, came out on top. And the strangeness is worth sitting with. Squeezing a handle produces no movement, burns almost no energy, and trains no visible fitness. Yet it changes the pressure inside your arteries weeks later. This channel is about mechanisms, not advice. And this one is a genuinely good mechanism. It runs on blocked blood flow, a gas made by the vessel wall, and a rebound that happens the moment you let go. 2 minutes of squeezing. Nothing to lift, nowhere to go. Let us look at what pressure actually is first. Section 1. What blood pressure actually is. 2 numbers, and most people have never been told what either of them measures. The top number is the pressure in your arteries at the moment your heart squeezes. The bottom number is the pressure that remains between beats, while the heart is refilling. The bottom one never drops to 0. Your arteries stay pressurized all the time. And that resting pressure is set mostly by one thing: how wide or narrow your small arteries are. Narrow them slightly across the whole body and the pressure inside rises, for the same amount of blood in the same heart. So high blood pressure is usually not a pump problem. It is a pipe problem. The vessels are held a little too tight all day for years, which raises the obvious question: what decides how tight they are? And the answer is a layer of cells you have almost certainly never thought about. The inside of every blood vessel is lined with a single layer of flat cells called the endothelium, 1 cell thick. Spread flat, it would cover a remarkable area. This is a large organ that happens to be arranged as a lining, and it is not passive plumbing. That lining constantly senses the blood flowing over it and tells the muscle in the vessel wall how tight to be. It is the thermostat for your pressure. Section 2. What the analysis actually found. Because the headline gets repeated badly and the detail matters. A network meta-analysis does not run a new experiment. It gathers trials that each compared a few things and reconstructs a ranking across all of them, including pairs that were never tested head-to-head. Every category lowered pressure. Aerobic work, resistance work, combinations of both, high-intensity intervals. This is not a story about cardio being useless. It plainly is not. Isometric training simply produced the largest average reduction of the categories compared. In round numbers, roughly 8 points off the top figure and around 4 off the bottom one. For context, that is a meaningful shift, the sort of difference that matters at the population level for stroke and heart disease risk. Not a cure, not a replacement for treatment, but not trivial either. Now the honest caveats, and there are several. The isometric trials were generally smaller and shorter than the aerobic ones. Fewer participants, fewer weeks. That is a real weakness. So the fair statement is this: isometric hand grip has a solid, repeatedly demonstrated effect on resting pressure, and it ranked first in this analysis. But the evidence base under it is thinner than the one under walking. Both things are true. Section 3. The mechanism. And it is a lovely one, because the useful part happens after you stop squeezing. When you hold a muscle contracted, the muscle fibers press on the small vessels running through them. At a sustained third of your maximum effort, that pressure is enough to squash those vessels partly shut. So blood flow into the working muscle drops while demand for it rises. The muscle is working and simultaneously being starved. Metabolic byproducts build up inside it because nothing is washing them away. That buildup is why the 2 minutes get uncomfortable near the end. The burn is not damage. It is chemistry accumulating in a compartment with the drain partly closed. Then you let go, and the vessels, which have been squeezed shut and are now surrounded by all those accumulated signals, open wide. Blood floods back in far above the normal rate. This is called reactive hyperemia, and that flood is the actual stimulus, not the squeeze, the rush afterwards. Because blood moving fast along a vessel drags on the lining as it passes, and that drag is what the endothelium is built to detect. The lining responds to that drag by producing a gas, nitric oxide. It diffuses out of the lining into the muscle layer of the vessel wall, and that muscle relaxes. The vessel widens. Squeeze, starve, release, flood, widen. 4 times, 3 days a week. Each repetition is a brief training session for the lining of your arteries. Section 4. Why repeating it changes anything. Because a single flood of blood widens a vessel for minutes. That alone would be useless. What matters is that the endothelium adapts to repeated demand, the same way muscle adapts to repeated lifting. Ask it to produce nitric oxide often enough, and it gets better at producing it. More of the machinery, faster response. So the resting state shifts. The same vessels, at rest, sit slightly wider than they used to. And because pressure depends on how narrow the pipes are, the number on the cuff comes down. There is a second contribution too. Sustained holds engage the nervous system pressure reflexes, and regular training appears to shift the balance a little away from the constricting signal. And here is the part that surprises people most. The effect is not limited to your forearm. You squeeze a hand, and pressure drops system-wide. Nitric oxide is short-lived locally, so this is not the gas traveling around your body. The leading explanation is the lining is one continuous organ, and training part of it shifts the behavior of the whole. That systemic part is still being worked out, and I would rather tell you it is an open question than give you a tidy answer that is not earned. Section 5. What happens over time? This one has no instant effect, and that is worth saying plainly before we go through it. The first session. During the squeeze, your blood pressure actually rises, sharply. Holding a muscle tight raises pressure while you do it. This is normal, and it is also why the safety caveats later in this video are not decoration. In the hour after a session, pressure typically sits a little below where it started. That is the short-lived version of the effect, and it fades. Around 2 to 4 weeks in, resting measurements begin to move in most people. Not dramatically, a point or two. By roughly 8 to 12 weeks, the full effect is usually present. This is the number quoted in the trials, and it takes that long to arrive. And it reverses. Stop training, and the adaptation fades over weeks, exactly like fitness does. This is a maintenance behavior, not an achievement you unlock. Section 6. The protocol. It is unusually specific because the research used one narrow recipe, and that is the recipe with evidence behind it. Step 1. 4 holds of 2 minutes each, with 2 minutes of rest between them. 3 sessions a week on non-consecutive days. That is about 14 minutes a session. Step 2. About 30% of your maximum grip. That is much lighter than people assume. You should be able to hold it for the full 2 minutes and finish uncomfortable rather than failing. Step 3. Alternate hands between holds, or use both. The trials have done it several ways. The consistent element is the duration and the effort level, not which limb. Step 4. And this one is a safety instruction rather than a performance tip. Breathe normally throughout. Do not hold your breath and strain. That combination pushes pressure up sharply and is exactly what you are trying to avoid. Step 5. Measure before you start, and again after 8 weeks, at the same time of day, sitting after 5 minutes of rest. Without a baseline, you will have no idea whether any of this did anything for you specifically. Now the serious part, and please do not skip it, because this is the one video on this channel where the caveat is genuinely load-bearing. During an isometric hold, your blood pressure goes up. If your pressure is already high and poorly controlled, that acute rise is a real consideration. If you have uncontrolled hypertension, heart disease, an aneurysm, retinal problems, or you are pregnant, ask a doctor before starting. Not as a formality, this does not replace medication. Nobody should reduce or stop a prescription because a number moved, and dosage changes are a decision made with the person who prescribed it, using their measurements, not yours. And blood pressure is not the whole of cardiovascular health. Aerobic exercise does a long list of things that squeezing a handle does nothing for. Heart function, circulation, metabolism, mood. This is an addition, not a substitute. Finally, the isometric evidence is real, but thinner than the aerobic evidence, and the ranking comes from one analysis. If a stronger analysis lands next year and reshuffles the order, that is science working, not science failing. So let us assemble it. Resting blood pressure is set largely by how tight your small vessels are. Their tightness is controlled by a lining 1 cell thick. That lining widens vessels when fast blood drags across it, and squeezing a muscle, then letting go, produces exactly that drag. 14 minutes 3 times a week, sitting down, holding something. No equipment beyond something to grip. No gym, no cost. And notice how this one differs from the others here. Humming, the doubled breath in cold water pressed a brake in your nervous system within seconds. Morning light set a clock. Walking after a meal opened a channel in a cell membrane. This one does none of that. Nothing useful happens on the day you do it. You are not triggering a response. You are applying a stimulus repeatedly and waiting for tissue to remodel. That is a completely different category of thing, and it is worth naming because it needs a completely different kind of patience. You cannot feel this working. You can only measure it, which is, I think, the honest reason it stays obscure. There is no sensation to report, no immediate reward, and the payoff arrives 8 weeks later as a slightly smaller number that only a cuff can show you. Every one of these has landed in the same place. There is machinery inside you running, whether you understand it or not, and its inputs are unglamorous. Sound, pressure, temperature, light, movement, and now simply holding on.